My sister works in urban policy and planning, and she's like, we don't need people building new bridges. We need people fixing the bridges we have.
Hello, welcome to Security, Cryptography, whatever. I'm Deirdre.
I'm David.
I'm Tom. We have a special guest today. I'll let our guest introduce himself.
I'm Justin Schuh. I'm the whatever.
Sure. And today, this is basically Platform Security Redux Part Deux, because we put out, this is in response to our first episode when we were trying to talk about why is iOS always on fire if it's supposed to be one of the best, the most secure operating systems in the world, quote unquote. And now we have more people to talk about what makes a secure platform. Are we wrong? Why are we wrong? Justin, why are we wrong and where are we not wrong?
Hey Justin, but before you tell us why we're wrong, can you tell us what would make you qualified to tell us that we're wrong?
That's a good point.
Yeah, I'll try not to run down my whole history. There are a few key points. So, start of my career was intelligence community. Listed in the Marines as a teenager, ended up doing also a few years as a civilian at NSA, followed by a few years as a civilian at CIA. Had a lot of exposure to offense, defense, et cetera, from that perspective. Then switched over a number of years of security consulting, which is where Tom and I first ran into each other. Co-authored a book, The Art of Software Security Assessment, some of you might be familiar with frankly better security people than me. And then last 10 plus years until just earlier this year, I guess I'd say, helped build out Chrome security, kind of depending on your definition of founding member. I was a founding member of the Chrome security team. Ended up being responsible for pretty much all of Chrome security and counter abuse by the time I left. And that was earlier this year. And now I'm retired.
I feel like we've established now that you're qualified to tell us where we're wrong. I'm trying to get my head around what it was that I said on that first thingy that we recorded, because my normal MO is just to like hear a couple words, then randomly reply guy stuff. But I remember us, David, you might remember this better than I do, but like we had some thoughts about bug bounties. I think like a perennial thing that comes up in these discussions is like, are the major tech firms paying enough for vulnerabilities? And is the problem here that they're just not taking researchers seriously enough? And then we had a lot of thoughts on Rust and whether we can just code our way out of this problem. I'm missing some things though, because we babbled for like an hour about that.
I think roughly kind of where we landed is that it is possible to have major security focused initiatives at large companies. We pointed to some of the things that Microsoft did in the past, their root and branch, so to speak, efforts that you described as removing stir copy everywhere. You and I think we're a little more skeptical that anyone could buy their way out of this problem, like buy the entire vuln market, because, markets are markets. Even if Apple decided to spend $1 billion a year buying all of the exploits, they probably couldn't. And then we pulled a number out of thin air saying, well, not entirely out of thin air, based off of empirical results from Alex Gaynor.
Yes.
And then our own opinions that a rewriting in a memory safe language would probably remove 80% of the vulnerabilities in the code base. And then we had this weak kind of notion that iOS and iPadOS are kind of easier to secure than, say, macOS because they are a more constrained operating system as compared to a MacBook.
With like specifically expressed capabilities per application and things like that.
And built-in sandboxing.
Yeah.
I would come out of the gate here saying like, I have like this ironclad conviction that I formed in 15 seconds when the question was put to us in that first podcast. But now it's something I'll believe forever, that the basic idea of a state-sponsored adversary is that they have an unlimited budget. And that goes for the United States, but also like the Seychelles or any like Belize, any country that you can imagine. The dollar amounts that we're talking here versus the payoff that you get for what an exploit buys you versus, for instance, having to pay for the health insurance of all the people that will do the human intelligence, that those numbers are so small relative to the value that there's no number that the market could realistically come to where that would make a dent on the market. So I guess that's like my first assertion. I wonder, Justin, I wonder if you'd want to knock that down. You've had direct experience on the state funded adversarial side of this as well. Am I crazy to say that?
Okay, so this is not where I disagreed with you. I actually like the way that I put it is that really you can't buy or bounty your way out of these problems. You're correct from the perspective of the person actually building the software and trying to secure it. They don't have unlimited money, but from your perspective, they do. Bug bounties, what they're really, really useful for is after you have some level of maturity and process. The problem is that security teams start to develop like groupthink. They start to get very, very blind to anything that they don't see day to day. And bug bounties are amazingly helpful at getting you a steady stream of input on the vulnerabilities that you're not seeing, the stuff that your team wouldn't look for. But then the right response to a bug bounty is to go back and, fix your process, find the scary areas of the code that you didn't know were there, fix them up, etc. On Chrome, we would, you'd see a trend of reports coming in and it's like, okay, it turns out that DOM objects are very, very loosely bound to JavaScript, and people are just getting use after freeze there. And it's like, oh, okay. Then you design a way to deeply root them. It's like, oh, it turns out you can blow up the render tree and stuff in the render, and you get stale pointers all over the render tree. It's like, oh, okay. Then you do a partition-based allocator structure where you can dispose of the whole render tree at once. And it's like, okay, now you've done that, but now it piles on, and that's what it's useful. So that is why I like bug bounties.
That's very cool. So it's basically a signal rather than like really the kind of trying to use the market dynamics to try and like push vulns one way or the other. It's for you, the defender of the platform or the software project or whatever, to be like, tell me what I'm not seeing. And if you're seeing a ton of little things in one area, you can triage that and prioritize that and what you have to do to make that better. Whereas if you're seeing like one or two really bad things in like one or two areas, like you can, that's kind of what you're,
Yeah, exactly. It's like you develop a sense of smell for it. These are the one-offs. It's like, okay, this was just a screw up, but it doesn't seem like a systemic problem.
Yeah.
But we're glad people found those. But the real use is oh, wow, this is a systemic issue. We have to solve this.
Cool. All right. How do you use that to inform how you plan? Because if you're just like getting a constant stream of like, I could see it being very vulnerable to just like kind of run around with like a chicken with their head cut off, trying to be like, oh damn, like there's like a stream of this. How do you use that to inform your planning of what to do when and re-architect things if they need re-architecting?
So this gets into the whole discussion of like embedded security teams versus what I call the throw it over the wall security teams. And the answer is that, so I refer to throw it over the wall security teams, and like the extreme case of this is external security consultants, where you hire someone to come in, do an audit, every 6 months, year, or whatever. And I did that for years. I did it in the federal government. I did it as a consultant. I do not like it. I learned that it doesn't tend to work as well, because the questions that you're asking about prioritizing and all that, you're not able to do it, right? The people with the expertise aren't part of those architectural decisions and that. And so from very early on, we were spinning up the Chrome security team. Our intent was to have a deeply embedded security team where like large chunks of Chrome code were owned or are owned by Chrome security. For many years, I was one of the 8 root owners of the Chromium repository. So I was one of the people who could prove any change in that. There are teams in Chrome security that are like deeper experts on some of the core Chrome code infrastructure than regular feature teams are. And so that's how you do it. You have to, I think it only works if you have an embedded security team and you've resourced them well enough so that they can make big changes.
Yeah.
I was say, do you think that the bug bounties have that same sort of third-party take use case to drive re-architecture or prioritization for things that aren't necessarily a web browser or an operating system? Like if I just have a large piece of SaaS software or a mid-sized SaaS software, can you get any value out of a bug bounty beyond PR. I guess is the hot take way of phrasing it.
So if you're just talking about sort of like, what does a bug bounty tell you? It basically tells you, have you staffed up a halfway decent security team? Like I will say, when we started the Chrome bounty, we were not ready for the onslaught of WebKit bugs that we got. And it was just, I don't know how to describe it. It was a tidal wave. And it gave us the insight that, we need to beef up our security investment more. This corresponded with the whole Aurora incident. So I was part of the response team on the Aurora incident.
I was going to say, tell us, what is the Aurora incident?
The Aurora incident was back in 2009 and 2010. It spanned late 2009 through 2010. It was when Chinese intelligence essentially compromised, not just Google, but compromised Google was detected, and then we found lots of other compromises, et cetera, as part of running it down. One thing that happened after the Aurora incident was Google took security seriously, but post-Aurora, it was a world of difference. I'm not saying Google ignored security. They had some very good people, but like the massive focus and investment. I mean, you had Sergey Brin saying he wanted the name Google to be synonymous with security and throwing the investment necessary to make that happen. And so conveniently, as there was a big push to invest in security, we were also able to respond to that bug bounty that we started by stepping up.
Have you happened to read Nicole Perloff's book, This Is How They Tell Me the World Ends? They have an account of the Aurora incident at the time as sort of like a history of the zero-day market. I think it's quite good, but you were there, so maybe you could tell me otherwise.
I have not read the book. I will admit that I've seen several excerpts from the book and like heard interviews of that made me less inclined to read the book.
Okay, fair.
But all I know about the book is that they were mean to Dave Vitale. That's like the one thing I have about the book is that it was mean to Dave Vitale.
I have the book on my shelf, but I haven't read it yet.
I mean, a lot of people have been mean to Dave. I think he almost revels in it a bit. At some point, you have to have Dave on. But what I would say is one of the fundamental premises of the book seemed to be you can buy your way out of security vulnerabilities, which I guess maybe like the NSA or whatever could audit their way out of it. And I've already expressed I disagree with that fundamental premise. Unless I'm misreading. I see an expression that makes me feel like I'm misreading.
It's kind of like this is happening and we are all vulnerable. Like we users of software are vulnerable, and it's just sort of it culminates with like this wave of ransomware attacks across the world in the past year plus or whatever. And it's just sort of like, we've got shadow brokers just like releasing these exploits based on this like 5-year-old zero-day windows that they sat on for ages. And now we're all screwed because someone got that out and it got, turned into, I forget which one it was, not Petya, one of those. And we're all screwed. And this is happening. And that's kind of the thing. Like there are bug bounty markets, but it's not so much that they are good and they solve the problem. It's just that they exist. And also, oh my God, everything is insecure. We're all going to die.
I guess there's some interesting dynamics. Justin and I have a shared background in security, software security consulting work, right? And there are some really basic things you learn quickly when you're doing consulting. And one of them is that even for really excellent teams that have really great track records of, doing assessment work, right? If you take 3 different teams and throw them at the same target, there'll be a 60% overlap or maybe a 70% overlap in what they find, but different sets of eyes will definitely find vulnerabilities. Also, one thing bug bounties do is they optimize for the number of different eyes that you get there. Also, I think the incentives of bug bounties are probably really good for finding systemic issues because bug bounty people are motivated in a way that consultants aren't to find variants of things. So as a security consultant, what you're really kind of fighting against or what you're working against is boredom when you're going after a target. So the temptation is always you find a pattern of vulnerabilities, you find the game over expression of that vulnerability, and then you report it as systemic, right? And then you've done your job, right? I found more than one, and here's the game over version, so you have to take it seriously. And now you're the engineers, you go do the work. And bug bounty people have exactly the opposite incentive.
Are you making a cathedral and bazaar argument for,
Yeah,
for bug bounties?
I said
Thomas?
I used the word eyeballs and I immediately regretted it. So it was in my brain when I said it, and like it's very bad, and I'll find a different metaphor so that we're not invoking that. But like my experience with bug bounty people has been like they're incredibly motivated to find and get paid for the most minute variations of things. So like we've had clients where like before we got to those clients, they had paid out, several rounds of bounties for like the same redirect vulnerability. Just like an open redirect on a web application, and like they break it with a filter and the filter's broken. Like they report that 5 or 6 times. And like the first thing you do when you come in there and say like, okay, we're done with the redirect vulnerabilities. We'll go track them down. That's the dynamics of how that works, right? Is like you find a pattern of vulnerabilities, then you scour everything for it because you're making money on it, right? So like the incentives kind of line up with trying to flush out. I don't know how true that is in large scale like product work like Chrome, because I've never worked on a team like that. Manning bounties for SaaS products, that was definitely one of the values that you got out of it. Also, like bug bounty people find different bugs.
Yes.
There's less status involved in the work that they're doing. There's definitely a bias in consulting to look for high status vulnerabilities or interesting vulnerabilities. And bug bounty people are, I was going to use the word shameless, but it's not shameless. It's like what we're doing is shameful. What the bug bounty people are doing is probably correct.
It's like if they find something and they'll get paid for it, they'll submit it. It doesn't matter if it's like the best or the shiniest or the coolest or, novel or whatever. It's like, does it work? Does it count? Here it is. Give me it.
Yeah, they're just ka-ching, ka-ching, ka-ching. That is their goal. And yeah, consultants will find you a different class of vulnerabilities. And yeah, I spent a lot of time as a consultant. You're kind of going for this flashy report, as Thomas said. And yeah, you see very different things from consultants than you do from bug bounties.
The exploit developers who are like selling to NSO and so on are probably finding yet another, well, maybe not a completely different class, but they have different incentives again, because they're trying to, one, they're only looking for the game over versions, or they're more interested in things that could turn into the game over versions. And they don't have the PR aspects associated with submitting to the bug bounty. They're trying to develop a product almost.
Yeah, I don't know if it's so much a different class. It depends on like which shop it came out of, right? It's not a huge number of people that are actually doing this, right? You tend to have different people, different styles. I think it in a way it's almost more like personal style plays into it. But at the end of the day, I think when you were talking about it, you were talking about how it's now become like a service industry, and it's actually been a service industry for a long time. Where it was a long time ago that people would just sell a proof of concept and hand it over to whoever's going to use it in the wild. Now it's like they got to keep these things up to date. There are service contracts, stuff like that. It's a big freaking business, and they have to support this software. You're not just, hey, I found this bug, here you go. No, there's a lot more to it.
I think we all know that there's like the work of actually producing reliable exploits. There's a division of labor, right?
Yep.
So there's like the finding of vulnerabilities and qualifying vulnerabilities, and then writing a proof of concept, and then fully weaponizing and making them reliable. I guess like here's a place where I'm flying completely blind, and all of you might know better than I do. But like, how much of that division of labor is expressed in the marketplace, right? Do we believe that like NSO has a team of people that can take really bad proof of concept exploits and then they can internally just weaponize them? Like they don't have to care about how easy the vulnerabilities are to weaponize? Or is it the researcher themselves that has to do that work, figuring out how to like bounce through this set of allocations and all that work? And the reason I ask is that, like, if it's the latter, if it's the researcher that has to figure out how to make the exploit reliable, then there might be an argument for reducing the supply of those experts, by paying more to bounties and things like that. But on the other hand, if it's NSO doing most of the, or whatever the thing is, right, doing most of the reliabilizing work, then you have a much broader pool of people that can potentially find those vulnerabilities, and then NSO can just full-time the people that can take that work and turn them into reliable exploits.
So accepting that any detailed knowledge I have on this is fairly stale, I think what Deirdre said about it might be in between. From my old past understanding, it depends was my experience, but this is knowledge that today might be stale. Like it's entirely possible things are much more productionized than they used to be.
My understanding from the Black Hat talk a couple years ago is that the more reliable your exploit is, the more you will get paid by the firms buying it, as well as like they will spend effectively engineering effort productionizing your exploit, but obviously the less they have to do of that, like they'll
The better
they
the
would
ROI
prefer
for
they
them.
would prefer to spend money to do less of that.
Yeah.
Because everybody wants to spend money instead of doing software development. But I imagine that they have to do some of it anyway because they
Yeah.
they want to like hook it to their command and control or
Yes.
pick what payloads they're sending. Even if the use after free is completely reliable to get whatever they want to send in, they still need to decide what they want to do with it.
Yeah, exactly.
Do we think like the white market for vulnerabilities, whatever the word is, because white market sounds terrible, but whatever like the above board market for vulnerabilities is, do we think those vulnerabilities are undervalued right now? Or, I don't know, right?
Like
But like
Apple and like vendors.
What do you mean by above board
Yeah.
market?
You're just saying
Apple-
like bounty programs, right?
bounty programs,
Okay.
yes.
I don't think it's undervalued because I think you're trying to do something different. I mean,
Okay.
like we're at a place where it depends on the vendor. I would say that people who I talk to, they find Apple's terms on their bounty program to be onerous.
Mhm.
So that is one thing. I would say that people generally consider Chrome's terms to be fairly amenable.
And those are like the conditions and the terms, not the like pricing, right?
Correct.
The like
Yeah,
how you
let's-
submit and when you get to talk about it and when you don't and how they respond to you type stuff.
Well, yeah, and also, frankly, what counts as in scope, what counts as out of scope, et cetera. Chrome has, my perspective on Chrome is that Chrome has always been fairly open-minded on what counts as in scope.
What would you change about the Apple rules if you could like move in right now and just fix them?
So this is the problem. I haven't actually sat down and read their terms. I've mostly heard grapes. And so I can't say exactly what I would change. My impression was that actually, I probably shouldn't even give an impression that might be totally uninformed. All I know is that
That's the
the
whole
people,
point of the show.
Well,
basically the big complaint that you would get is like haggling over what counts as in scope, haggling over what's rewardable, et cetera, being very ambiguously defined.
Mm.
what does it mean to like have the use of the Chromes was more open as to what counted in scope? What does it mean to do that versus not?
So with Chrome, there was a lot of effort put in to get pretty specific about what was rewardable, why, what counted as a security boundary, et cetera, both from an engineering standpoint, because it made it easier internally, and externally made it easier for people reporting bugs. Like for a bounty hunter, for bug bounty hunter, they don't want to,
For both
they don't want to burn a lot of cycles on something that's not going to pay money, right?
Mhm. So I guess one thing that is hard to tease out is there's prices, and it's hard to tease out whether the prices for bug bounties are actually moving markets or moving people to report to vendors to the white market as opposed to the gray market or black market when you've got these differing terms between bug bounties that may also be affecting what gets reported to whom.
Yeah, but I think you're dealing with fundamentally different groups of people
Okay.
between these markets. I don't think there is obviously going to be some overlap, but I don't think there's a ton of overlap between people who are doing bug bounties and people who are selling stuff to NSO, et cetera.
Okay.
On my sample size of one, the one person I know who's like actually sold exploits does not submit to bug bounties at all.
Yeah. The people, like, you interact with the people who do the bounties, and they're like, so Chrome's, as an example, actually, perfect example, for Chrome's, it's like, you show memory corruption. We don't require you to prove that it's exploitable. And in fact, I think there's a good chance that Chrome rewards lots of memory corruption vulnerabilities that are not pragmatically exploitable.
Huh.
But it's like, this is the line. If you can demonstrate memory corruption, and that means that it just makes it easier because you don't have to write an exploit or anything else like that. You just have a simple proof of concept. And Chrome's, like the Chrome's own systems will do the minimization and everything to try to create a reduced test case. So it's relatively low friction. There are a lot of things that Chrome does to incentivize people reporting, and to make it easier for reporters. It was just it was part of the culture that created the program, and it's carried its way through.
I love that.
But like I said, it's an input channel. You want to get that signal. You want to get a strong signal.
I feel like the top line of this discussion is always just the idea that like a reliable RCE or whatever is, I mean, people on message boards think that, logout CSRFs are worth, $10 million or whatever. Just like come up with like some percentage of the total market value of a company, and then that's the value of a vulnerability. But like, there's like a general idea that like, a reliable drive-by, iPhone remote or something like that has some kind of market value that we can assign, and we should be paying the actual market value for that vulnerability for it. I'm pretty sure I feel like that's wrong, right? Like I'm having trouble putting my finger on why I feel that's wrong, right?
Because
right
it
this
sounds
second.
like they're not one market. It's different markets. And so it's impossible if they're not playing in your market, they're disjoint. So what are you doing?
Yeah,
Does that make
exactly.
sense?
That's my take. Being responsible for that program for several years is that you're dealing with different groups of people. There might
Okay.
be some overlap, but I think people have this assumption there's overlap, and that's not something that I observed in practice.
Basically, you can't model them as like, oh, if we raise a price over here, that will incentivize the same type of reporter to come over to here. And it's like, no, except for outliers, that's not true, basically.
Yeah.
I mean, just a devil's advocate, it, right? There isn't perfect overlap, right? Like there's a lot of work that somebody who sells functional exploits does that a bug bounty person for the Chrome bounty doesn't have to do.
Yeah.
And they can go for breadth and not depth, and the other person has to go for depth and all that, right? But in theory, if you dial the incentive up enough, you can have the bounty people, flush out. Both groups of people have to do that initial kind of reconnaissance work of finding where the vulnerabilities are in the first place, right? So in theory, if you dialed the price up enough, you could have the bounty people finding vulnerabilities before the exploit people do.
Potentially, yeah. I should clarify that the Chrome bounty program also does have incentives where it's like, hey, look, we will pay you a lot more if you can produce a reliable exploit.
Right.
And if you chain a series of reliable exploits together to produce like a full sandbox escape, etc., within a certain time window, we will like pay you for that full sandbox escape. And there's a lot of details to the bounty program to try to sort of maximize the kind of information that you get and to encourage people. But yeah, at the end of the day, most of the reports are not people who are running it down and building a full exploit, etc.
I saw a talk recently where they were saying that bug bounties need to allow people to like work on a bug over a period of time so that they can take it from I found like your initial bug to I have a full working exploit. Like, is that a thing that's feasible to do? Because it seems like you might just want to go fix the thing. Like if you learn that you have a memory corruption, you might just go fix it before the person writes a full exploit, even if you did have that type of fallacy.
No, that's the way that the Chrome bounty is actually structured. So that it's like, yes, it was that version. Like the engineering team went and fixed it, but you could still finish off. Because the idea is you want them to report the vulnerability as quickly as it's confirmed. But if you want to encourage that additional research, you also have to have that extra flexibility in the program.
Yeah, because I think I saw someone on Twitter was saying they had found the bug that was used by the NSO group on the iOS, and they didn't report it because they didn't have a full working exploit yet. They had just located the bug, and they wanted to turn it into a full exploit.
Okay, that's not a good term.
No, but
Maybe it wasn't the NSA bug, but it was a bug in Apple that was similar, something that's been patched recently.
You can see right away the incentives there are terrible. If you've got a condition in your bounty that asks people not to report until they've done all of the work for it, that's awful.
Oh, no, but that was we made that mistake when we originally designed the program and started adding like extra things where it's like, okay, for a full sandbox escape chain, we'll get this much. And so people started sitting on things. And we realized they were sitting on things. We're like, okay, we are updating the program to account for this.
Okay, so how does it go now? So how's it go to avoid that?
Oh, so some can report the bug. But there's like my recollection is that there's a time window. I'll throw out 6 months. It might be 6 months where it's like from when you report the one bug and you can keep reporting bugs and sort of chain it together and develop, full exploit, et cetera, and kind of keep racking up a higher payout as a result. Thus, you're going incentivized to report the first one earlier because they're also worried about collisions, right?
Right.
And you do get collisions. I think people dramatically overestimate the volume of collisions, but everybody gets collisions. And this was the thing that we had been hearing, like what we heard from like good reporters who had regularly reported bug stuff. So like, oh, I found that one, but I hadn't reported it yet because I wanted to develop a full exploit or I wanted to try to use it in a chain. And that's why we revised the program.
Okay, so basically, if you're first, you get first dibs, but you get to keep racking up your score if you get like a fully working exploit, repeatable exploit, a kill chain, and so on and so on. Cool. I like it.
So if David reports a memory corruption vulnerability to Chrome, without the rest of the exploit chain attached to it. And then I come in. This is a fantasy world where I do browser exploit work, and I'm not totally incompetent at that stuff now.
Also a fantasy world where I can do memory corruption at all without screwing up the math. Like I taught intro computer security before, and for the memory corruption part, I would bring someone else in to teach it because I can't subtract 2 memory addresses to save my life, even if I could tell everybody where the vulnerabilities were in their assignments.
It was so easy when Tom and I started out.
I remember feeling very cool and special for coming up with shellcode that didn't have any uppercase letters in it. Like,
Yes.
For a while, that was like my calling card. Like, yes, I'm definitely I'm very solid at this stuff. Here's this exploit I produced. It has
Or
no uppercase letters.
UTF-16 shellcode meant you were like a freaking master. And yes, yeah.
Yeah, no, it's definitely gotten worse, right? But so in this weird fantasy world, right, where like David submits the memory corruption vulnerability, and then we collide on what the vulnerability is, but I submit the bug chain that goes with it. Do we both get paid out?
No. So the program, as far as I recall, is still entirely first come, first serve. Different programs have chosen to do this different ways. Some people say, hey, look, if a group of people reports it within this time interval, they each get a cut of it. But the decision was made very early on Chrome team that the first person to report is the one who gets the bounty. And part of it's just because when you dupe a bug report, it's just there's a certain logistical thing to it, but also I think it's just fairer to say first one to report gets it, because then you're incentivizing people to report quickly.
Yeah.
And hey, Boba Fett doesn't get paid if he's not the person that gets the kill.
Bounty hunters.
So like I guess for many years, for a while, I think David was involved in this a little bit, and so was Deirdre. We did some security work for campaigns in like the election cycle. Before this election cycle, we did it kind of big time. And we came up with a bunch of security recommendations for kind of ordinary people. And like our top line recommendations, like things that we would tell normal people to try and understand like the threat landscape, would be that for phones, we'd recommend iPhones, that like every iPhone was, more secure. Just generally, I'll be more intellectually honest about it and just say that at the time we said iPhones, iOS, just more secure than Android. Yep. But that on the browser side, I would strongly prefer Chrome over Safari. And I would say right now, I kind of stand by the Chrome and the actual Chrome or Chromium project, and not spinoffs of Chrome or Chromium.
As you should.
Which would be kind of my gospel on what browser to use. And I still tell people, and I believe that, iOS is more secure than Android, although there's like a meme going around ever since that Zerodium thing came out where we're not paying for iOS vulnerabilities anymore. There are now people that believe that iOS vulnerabilities are worthless. So I guess I have 2 questions, right? So I'm iPhone over Android, and I'm Chrome over Safari. So I'd be curious to see your thoughts on whether I'm wrong about that. And then I have a spicy question to add to this, which is, what about Firefox?
Yeah, I was about to say.
All right. So what I would say is that I am personally Pixel over iOS.
Yes.
It is correct that if you're just going to compare Android to as a whole to iOS, then you are dealing with a massive and extremely varied ecosystem.
Yes.
But Android deservedly had a bad rap for security. The amount of investments and everything that went into that over many, many years now, I feel has changed that game. I think where it gets more complicated though is it's not like Windows, right? Where they control the image. They can, and even in Windows, there's like, who did you buy your PC from? It might have had a bunch of extra stuff on it, et cetera. And that's the thing. Even on Windows, because it's a big ecosystem and not just one vendor, that you get that you're exposed to a wide variety of things. And I am very much on the side of a well-configured Windows 10, like a decently configured Windows 10 machine is a safer bet than say Mac OS. Oh yeah, I'll go on that one too.
I'm with you on that.
Yeah.
If I've learned anything from Swift on security, that's basically true now.
What does it mean to be decently configured though?
I mean, basically, there's a lot of bundleware stuff that out of the box. And what I should decently configured is basically, did they install a bunch of bundleware? And Microsoft has gotten really aggressive at trying to prevent the kind of dangerous bundleware. So I think a new Windows 10 machine actually comes relatively safe.
So like a clean install by a power user counts as decently configured.
Cool.
Yeah, but I think most of the stuff you're getting in the store, because Microsoft has been so aggressive with the way the Jumpstart incentives and everything works, they can't do the same kind of bundleware they used to see. But yeah, the reason why I would pick Android over iOS is that, or specifically Pixel over iOS, is that in Pixel you're getting monthly security updates. You are getting essentially the most hardened version of Android. The browser is a massive attack surface. And yes, I will go into detail why I would put Chrome up against Safari any day of the week. But I think that's one of the areas where you have a ton of attack surface and it's just much stronger. To get into the why
Yes.
of Chrome over Safari.
Before you say that, I have one question about
Yes.
Android. So, as you know, I interned on Chrome security back in 2016, and I kind of remember the general attitude amongst people that were not on Android at Google about Android security circa 2016. Has that tenor, how has that tenor changed? Like, do you think there's been major improvement since 2016? Or was Pixel being good, everything else having bundleware issues, kind of the state of the world back in 2016?
In 2016, they had started to work long before 2016. Like point blank, Andy Rubin was hostile to the idea of security. Like remember, he went and started another phone company, and they listed all of the staff, and for the 2 security roles was Andy Rubin's dogs. Like he didn't conceptually. He argued against security, and so I would say that things started dramatically improving after Andy left, and we can all agree that Andy's attitude towards security was probably among the least of his flaws. It takes time, right? Like you can't move a ship that big overnight. And it took time and a lot of work. And the Android team put in a lot of time, put in a lot of work. I don't know, I've seen a lot of improvements, but it took time for those improvements to really have an effect.
Okay. This plays to some of the things we were talking about in our first episode about iOS security. What were some of those things that you had to turn the aircraft carrier around to accomplish? Architectural practices? Give me the meat.
Yeah. All right. So I was not on Android, so this will be in reference to Chrome.
Like you were at Google. So.
Yeah, but honestly, it was Google's. So the thing about Google that I think
Google's weird. It's like all these orgs, especially like Android and Chrome, and then there's like the rest of Google, and there's like search is its own like Citadel.
Yeah, exactly. Orgs that Google operate. I spent a lot of time going in and out of companies as a consultant. I saw the deep internals of how the U.S. government worked in a lot of places. I have never seen the level of sort of independent organizational operation elsewhere that I've seen it like Google. And I was in the Marines where a general was basically like, my base is my base. And I'm still like, yeah, he doesn't hold a candle to an SVP of a product area at Google. So yeah. But yeah, but I can't give you examples from Chrome. So site isolation was like fundamental re-architecture of huge swaths of the browser. You had Nasko Oskov and
Can you
his
explain what site isolation is as
sorry.
compared to whatever type of isolation was before?
Can you give me a couple sentences that I can just drop on people on Hacker News for site isolation?
This is a fair point. So site isolation was designed around the notion that, so we have this good process sandbox. And if you can say, hey, we are going to bind the process sandbox to an origin and say, if you open up something on google.com, only google.com is going to go in this process. So the idea being, instead of having to do a whole bunch of checks all over the code to determine if one origin can interact with another in ways that, memory corruption in even the renderer process could bypass, you say, no, look, this renderer is google.com. It doesn't get to touch anything outside of google.com, and nothing outside of google.com gets to dig into it.
And it's HTTPS or HTTP. The
so
origin is HTTPS google.com, not HTTP google.com. Those are different origins.
Yes. So, and this is why it's called site. The definition of site is fuzzy because it's not truly an origin. Yeah. So HTTP is kind of in the doghouse, that's in the dirty bucket where you're like, we can't really make guarantees with HTTP, but yes,
we will just upgrade you forever now. Thank you.
That is actually the strategy of solving the HTTP problem, to eventually upgrade everything. But yeah, it's essentially effective top level domain plus one goes in its own process. And that just makes the security reason around origins so much simpler. But one of the really nice things it gets you is that if you get code execution inside of a renderer process, so like you compromise V8 or whatever, you still have to find a way to bypass site isolation to manipulate any other origin, like the old model. And this is frankly the way that the other browsers work. yes, still is that if you get code execution inside the renderer process, you effectively have universal cross-site scripting. But in Chrome, if you get code execution inside the renderer process, you are still bound to EverOrigin hosted that. Now, there are some exceptions where it's funny. Usage patterns on desktop allow you to do a bunch of coalescing of processes, but usage patterns on desktop are very different from usage patterns on mobile. On mobile, you don't have the same kind of coalescing. So instead of applying site isolation everywhere, on mobile, site isolation is there are various heuristics that are used to determine if, this site needs to be isolated. Like one of them being if we detect that you've logged into the site, that it's like, okay, it definitely needs to be isolated, et cetera. They are doing as much as they can to get the resource utilization down.
Performance?
Yes, it's a resource utilization thing.
Okay.
And they keep sort of expanding the set of things that can be isolated. But right off the bat, if you're isolating things that the user logged into, that's already helping a lot. So site isolation is not perfect, but it is a huge win. The other thing I would say in terms of like a big advantage of Chrome over other browsers is Chrome has a much more robustly sandbox renderer process. The Chrome renderer process doesn't have access to the network. It does not have access to graphics devices. It does not have access to the input event stack, etc. Like all of that is split out because the idea being that like you remember the old Windows low integrity mode, or for anyone who does remember the old Windows low integrity mode, the problem is that there was a lot of ambient authority because you could fire off events. So there are a lot of ways to abuse input, to abuse access to the graphics stack. You had you had all of these things, and that was why people were always finding escapes out of low integrity mode. So from the beginning of the design of the Chrome renderer process, the intent was to have none of that.
How does the renderer not have access to the graphics card? Is there a separate actual renderer?
There is a GPU process, and the GPU process is sandboxed to the degree it can be. So this is the other piece where it's like people talk about sandboxing like it's a binary state, where it's like, no. Sandboxing is an approach. It's like what you allow in, what you allow out. There's a tremendous amount of variance there. So it's not the kind of thing where you can say, it's just sandbox.
This goes to something that you might have been already wanting to talk about, but you can't mitigate your way out of a failure to isolate your software along its security boundaries. So that seems to directly be about sandboxing and other things.
Well, it doesn't just have to be sandboxing, right? Like there are other ways to isolate, like memory safe languages provide forms of isolation. The V8 team just made the announcement of, I think it's calling it Uber Cage or something. Where,
what?
Well, because I think it's Apple already took like Giga Cage. Also, they're a German team, so you know.
Oh, cool.
But the idea being that they already had to do this thing called pointer compression, where the V8 runtime is actually only dealing with the 4 gigabyte address space. But what they're doing is it's actually quite similar to the design of the old 64-bit NACL sandbox. They are bounding operations within that address space, and they're providing large ranges to block the edges of that address space. So that's another, now we're not talking about a process level sandbox, but we are talking about something that provides guarantees about confined execution. You can't touch anything outside this address space. And so like they're working on that right now. You know, rewriting parts in Rust are another example. There's lots of different primitives that you can use to isolate, reduce your attack surface. One of you said on that episode something about how good is pack when you're dealing with bundles of messages, dynamic dispatch, something along those lines. And
I think
my
it was
take
like
on
iMessage and stuff.
And this is my problem with. So this was one of my complaints with sort of the Apple strategy that I've been observing. It has a very similar smell to the Microsoft 1990s strategy, where it's a sort of a belligerent approach to how they deal with vulnerability researchers and deal with the security community. And they're layering on mitigations, but mitigations aren't going to solve your architectural issues. You just have to get in there and fix the architecture.
Would you consider Blastdoor a mitigation or an architectural change?
I have not taken it apart to see.
Well, neither have I.
And that's I don't understand what it does well enough. Right? Like it's like, okay, we wrote this in a memory safe language and we maximize the seatbelt policy. I would like to see the seatbelt policy to get a sense of what it is. But it depends, right? I don't know if anyone seen me go on a rant against Electron. But my problem
Please.
So my problem with Electron is that with Electron, people would complain, they shut off the sandbox. I'm like, I don't care that they shut off the sandbox. I care that every Electron app opens these IPC messages that even if you were sandboxing things, it doesn't matter. It's like the thing on the other side is still exposing all of its attack surface. And so that's the thing. I would have to, so you'd asked about like architectural things, like process wise, it's very important to have your security team deeply involved. So Chrome has a very strong code review culture. You have to get a code review from an owner before you can land things. The IPC message system, and when you create new IPC messages, et cetera, that's owned by the Chrome security team. Yes, interprocess communication. Yeah, because that's your main attack surface between different sandbox processes. That has to be reviewed. The normal code review process has to go through one of the qualified reviewers on Chrome security. And so anytime you are bridging that attack surface, you have someone who, should have sufficient security expertise reviewing to try to catch errors, catch mistakes, catch things where like, oh, you just added a backdoor and you didn't know it. Because it's really, really easy to do that.
I have so many questions that I won't keep us too long on this, but I'll ask too, right? So with regards to like the success story for Chrome, I guess this is 3 questions, right? So first of all, when you read published accounts of bug chains and things like that, like I feel like there's a survivorship bias in terms of what you're reading. Like the bugs that we're reading about, it would seem from reading it like that the sandboxing isn't working at all, right? Like every vulnerability you read about comes with a story about how they then bypassed all the the sandbox and then got a kernel LPE and things like that, right? So I guess I have 2 related, first of all, questions about how successful do you feel like the sandbox is? Like, what do you think its success rate is at cutting memory corruption vulnerabilities off? And then I guess my other related question is, if you had to like do like 100% of Chrome security and divide it up, sandboxing would own what, 60% of that versus runtime hardening, or 80% of it versus runtime hardening, or?
That is hard to say. There's not a lot of development left on sandboxing, like in terms of the actual like ongoing work where it's like, it's the architecture, it's built, it's this way.
Yep.
I would say the next big thing in Chrome is to memory safety, but it's something that you have to it's something you have to roll in slowly and carefully. And I made a comment to all of you beforehand about you can't rewrite it. Rust is not a strategy. It just logistically it's not a strategy. There's way too much code.
But you can rewrite parts in Rust.
Yes, and I think rewrite parts in Rust makes sense. Then again, there's a lot of things that could be done to fix C++.
Okay, hold on a second.
Sorry.
We have a good segue here, right? But before I let you fully take the segue,
yes.
Speaking of Rust, I'm not going to let you off the hook on Firefox.
Yeah.
So simply by looking at the security architecture and that, I think the Firefox team does really well, but Chrome has a more restrictive sandbox. Chrome has proper site isolation. Chrome has more isolation between different processes by capability. There's a network process, there's a GPU process, etc. So I think Chrome just has a better architecture. I think the Mozilla team does amazing with the resources they have and the architecture, the extent to which they've evolved Gecko to make it safer and more multi-process. And they're introducing a form of site isolation, which is essentially address space isolation, which will address things like Spectre vulnerabilities, stuff like that. So I think they're doing great work, but I'm still when I look at the breakout and the numbers, I'm going to recommend Chrome.
Sure.
So why hasn't Chrome been rewritten in Rust?
Because it's millions and millions of lines of code. So I spent a large chunk of my time on Chrome actually managing non-security teams too. There were just different points where, because of situations, I took on the desktop team, I took on the extensions team, enterprise team, like various different teams where I was responsible for. I say team because it's an org than more than a team for many of these. But I had to intimately learn about like staffing and prioritization and all of that and figure out how to balance all those things. And so I look at Rust and I say, okay, you could not feasibly rewrite it in Rust. I look at Rust and I think that I think it's crazy to not be testing out Rust for certain parts of the code. For like, there are tons of places where you could be making targeted uses of Rust, and it is the right call right now. Rust is mature enough, etc. Then again, I've been playing with Rust since I am no longer employed.
What do you think? I started writing Rust like last year, so
I do not like the developer ergonomics of it so far. I do not like the available. And it might take some getting used to. I didn't like C++ at first either, but when I look at it logistically, I have I can find C++ programmers. I can do a lot of things to add safeguards and partition things, etc. I can staff teams. It is hard for me to find Rust programmers. The Rust programmers are probably going to be significantly less productive, if only because you don't have the full set of like existing code, etc. Like it is just a very expensive proposition. Like even in my side projects that I'm doing right now where I was trying to use Rust, I've given up on using Rust for the majority of the project because I would have to rewrite a whole bunch of code that I already wanted to use that was available. I'd have to rewrite it in Rust, and I'm like, this is just an exhausting experience. So instead, I partitioned out, and it's like, okay, I'll use Rust over here, but I'm not going to use it for the meat of the code. And I think that's actually a reasonable strategy. I wish that the people that started Rust had taken more of a C++ style approach to it, which is figure out a way to build a bridge between the languages. It is painful.
Not the FFI interface?
Well, the FFI interface, though, but it's not going to let you port existing code, right? So that now you can write new code. There's actually someone on the Chrome team who, on Chrome security, who's been doing a bunch of work on improving, C++ compat with Rust, because there's still a lot more that can be done. But like, take the FFI interface. You're not going to get C++ objects, right? Because that's not standardized, et cetera. And yeah, it's hard. I would say that if there'd been a way to create essentially a dialect of C++ that you could piecemeal port with similar guarantees to Rust, you wouldn't necessarily get all the same guarantees. I feel like that would just be so much easier logistically.
Just have a giant unsafe block and just copy paste your C++ and then just fight with Rust C until it compiles.
Well, isn't a dialect of C++ also known as Gecko? Like, isn't that thing whole just written in macros and macros and macros?
I mean, if you're using macros in C++, you're almost certainly doing something wrong. But yes, there's lots of legacy code. There's a lot of ugly parts of C++. I'm not defending the language in its entirety, but the fact is that pragmatically speaking, it's really hard to find something else for something like a browser.
You're practically starting from scratch in a lot of areas. And the areas where you are not is like small pieces. And, I've been working on a full Rust project for over 2 years, and we were only able to get started because we had things like the Tokyo Async runtime to build on top of, and a bunch of libraries that we built on top of. But we're also doing a lot of architectural stuff from scratch.
Yeah, and that's why I just don't think rewriting Rust is an option, because I mean, look what happened when Mozilla tried to redo Gecko, or when it became, it was Netscape at the time, and they were like, they were going to redo their runtime, they did Gecko, et cetera. And even that still has a lot of weird quirks of the original engine, but that was years of work for that. And they were talking about a different language.
Yeah.
Last time you checked Chrome, would you say that the Chrome team is in a place right now where, to whatever extent the engineers actually doing the work on the project want to use Rust for things? Like if that team spots a component that makes sense to write in Rust, can they do it? Are there any other current logistical obstacles to doing it? Or is it like the Linux kernel where there's still a huge permissions process to get that work started?
I'm not going to throw anyone under the bus. But I will say that there are no shortage of strong opinions. And I think adding a new runtime, adding a new language, et cetera, it is always, for any sort of stable, mature product, and frankly, a product that has very high development standards, in my opinion, that's always going to be kind of contentious.
Yep.
But it's not like Firefox, where if the Firefox team spots something they want to do in Rust, they're just going to do it in Rust.
I'll say it's certainly not my impression, but this is the thing. I'm not involved in those discussions anymore.
Yeah.
And when I left, those discussions were, sort of rapidly evolving. So they might have evolved quite a bit.
The thing you get from C++ programmers, and I was a C++ programmer, but a long time ago, right? So people talk about modern C++, and I assume it's a completely different language than the one I was writing in 2001, right? But you hear modern C++ programmers saying that there's not that much of a security gap between Rust and idiomatic modern modern C++, in kind of the same way you might be able to make that claim about Objective-C versus C, right? If you're using just the idioms, you're probably okay.
Yeah, I mean, if you're using idiomatic modern C++, you're avoiding raw pointers. You're using own pointers and shared pointers. But then there's the question of your compilation options. Are your containers bounds checked or not, depending on how you're compiling it. I would say that, I guess the way I would put it is that idiomatic modern C++ actually opens up the opportunity to introduce some of the core concepts of Rust into C++, but then you're going to have to like break ABI, then you're going to have to get the standards committee on board, et cetera.
Yeah.
I think one thing that could just create a sea change is pointer tagging, because like you look at pointer tagging and you could actually you could essentially rewrite your allocator. So you essentially have like a GC allocator. You could do things like have an actual security enforcing ASAN, like address sanitizer built in into like a production runtime. If you have that hardware support for something like pointer tagging, what that will do is it will give you many of the memory safety guarantees of Rust. It won't give you all of them. You won't get the thread safety guarantees, but you will get a number of the riskiest ones. And I do think that might turn into sort of one of the paths of least resistance for C++.
I don't know. There's still just a lot of ways for stuff to go awry, even if you aren't like just doing stir comps everywhere. If you don't return a value from a function, the compiler can't always warn you, and it can still run like the. You can set compiler flags to help with that sometimes. You generally don't know if a pointer needs to be freed or not. Like if you're using it as an output parameter, your constructors might do God knows what when, like, depending on how you typed in your initialization.
But this is where I was talking about. If you have pointer tagging in hardware, you can actually make all of that behave far better. Your allocator essentially becomes like a generational GC, and it's just like rotating through the tags, and you can have even more fine-grained checks. I mean, you're paying the cost in the silicon, right? But once you pay the cost of silicon, you're not paying execution time overhead for it. So this is the thing. My question is, if you're going to have like widespread support for the kind of hardware you need, like pointer tagging, soon enough, so that rewriting in Rust isn't something that people are seriously considering for large scale things. Like remember, Mozilla tried to do the rewrite in Rust with Servo, and eventually had to give it up, and it was a huge undertaking.
I mean, a thing you'll get from Rust is
also the pandemic hit and they had to lay off like half of Mozilla. So I don't want to conflate why Servo has not succeeded with just it was hard to rewrite it in the brand new language we came up with.
I don't think it was just that. I think the pandemic was a smaller piece of, but I don't see Mozilla's financials, so I can't say.
Yeah, no.
Rust has like a security activist, language core, right?
Yeah.
And you could tell me that C++ has a security activist standards committee, but I wouldn't believe.
I mean, I'm not gonna ever say that because it's not true. No, the standards. My concern is that the C++ standards committee does not take security anywhere near as seriously as they should. I mean, there's the whole
sounds like Andy Rubin.
Well, no, because Andy Rubin was actively hostile to security.
Okay, different.
But yeah, there's the whole whatever the specifier is in C++ to say that you have to check the return value. And there's like a whole debate going back and forth about like they added it to the standard for 20, but they're like, oh, it's a lot of work to do this for all libraries and figure out which thing needs to check a return value and doesn't. So maybe we should just take it out and say, no, the standard library won't ever apply that specifier. And it's like, okay, that's a terrible idea. And so you get quite a bit of this where it does kind of feel like the C++. It doesn't. There's a lot of good things to learn from other languages, and I think the people working on C++ standards and the standards committee should be a lot more open to learning useful things from other languages.
Okay, to round out the Rust discussion, I want a Fuchsia phone. I want a Fuchsia computer, like a end user Fuchsia computer, not just like get a board and compile Fuchsia for myself.
Not just a NUC with Fuchsia on it.
I'll be honest and say that like whenever the topic of Fuchsia comes up, my brain just turns off. I just stop thinking about it. Like sell me on paying any attention to Fuchsia.
I don't know if I can tell you I'm paying any attention to Fuchsia because I don't know the future of Fuchsia. But what I can say is it is a very elegantly designed operating system from a security perspective.
And not just because it's written in Rust with a C++ microkernel, like the way they designed it.
Yeah, I would say the Rust part is even sort of like a smaller piece of it. It's just like from an architectural perspective, like a process in Fuchsia is not created with any ambient capabilities. It has to be like it is born into existence with nothing. And you have to actually consciously choose to hand over capabilities. Like the simplest, like it's funny, you look at the sandboxing code for Chrome on like every platform. It's like there's a whole bunch of work to go shut down all of the stuff that automatically gets turned on for all of these different processes, where it's like the Fuchsia renderer broker is like this tiny little thing that just essentially does nothing except for like set up the IPC channel or whatever.
So cute.
Yes, it is. It's a much clearer design. A good friend of mine is one of the lead engineers on Fuchsia. I think he described it as the love child of Plan 9 and NT. And for everybody who doesn't like Windows, you really have to take a closer look at NT. I think most of the things you don't like about Windows are the Win32 things, but the actual NT kernel, the core, the design, it was a very well thought out, very forward thinking design. And I think Fuchsia, it took a lot of the best parts of that, and it actually like incorporated lessons learned to that. So it's a capabilities based operating system. It really takes the capabilities part seriously.
Yes. And I think the latest I've heard is they are swapping out like the Linux kernel or whatever the base operating system for things like the Nest hubs or something like that. And they just sort of were able to like push it out and just be like, flip a flag, use Fuchsia instead of what you've been using since the beginning of your existence. And it just worked. Something like that.
Whenever you have to do firmware updates in the field, you're always going to have some number of things that just rando fail.
Sure.
But yes, a bunch of the existing Nest devices got the update. And it's just, because it's a much simpler operating system, it actually, resources quickly. The real issue with Fuchsia is that you don't have device driver support.
Yeah.
Like, remember the old Linux problems from the mid 90s? Like that's where Fuchsia is. Frankly, there's actually a bunch of stuff like
not that old. Like you still run into that when you're just trying to plug in random crap into your
That's
Linux
fair.
machine.
Although the reason why like Android and Linux based operating systems are so popular for embedded devices is because you do have driver support for all of that.
Yeah.
And Fuchsia has to build up that driver support. Like I have friends on the Fuchsia team, colleagues, etc., but I don't have any more insight into it than anyone from the outside would have. But I very much like the design. I very much like the decisions they've made. I also would look at it as Fuchsia has layers. It's entirely possible to sort of take pieces of Fuchsia and integrate them over time. And I think that's probably the best path forward. You look at something like the Nest devices where they didn't do a heck of a lot. So it's easy to build that on top of Fuchsia. But if you're looking at something like an Android device or a Chrome OS device, you would probably start at be like, okay, we're going to stop using the Linux kernel because these devices have hardware support for the, these drivers, et cetera. And we are going to swap out the Linux kernel and have a layer here above the Linux kernel. And you would just keep evolving that.
I like that.
That's just my guess. I am not speaking for anyone. I have no insight to how that would work, but I do, it is the thing that makes sense to me.
I am a fan.
Justin, you don't come across as a Marine.
I'm not. I was. I'm not anymore. That was 20 years ago.
If there's a group of people in a room and I was going to point out the one that was likely to be a Marine, it wouldn't be you. Is that a bad thing to say? Should I say that you come across as a Marine?
It was an important formative life experience.
I believe it. Yeah.
But it's the same point of, I bet you I could find pictures of you 20 years ago. And it would be like, that's a very different person that is in front of me today.
Unfortunately, probably not. I'm asking just because I'm curious, but of all of the service branches, why the Marines?
Marines are cool.
I mean, obviously, but
the Marines are cool. I knew Marines.
It was the hardest looking one. I dropped out of an art program. I was at Northern Illinois.
Who are you?
Up in DeKalb, and dropped out of a graphic. Well, they called it, I think, like studio art or whatever. At like 19, because I just got sick of college. I'm like, I'm gonna go enlist in the Marines. So that was how that happened.
How was that experience for you?
Useful.
Useful.
Yeah, I think I don't know. I think people should take opportunities like broaden their horizons. I think people tend to be. It's very easy to sort of just get inside your box, stuck inside your perspective. I think also there's nobody's going to say that I'm a kind-hearted person on Twitter or anything like that, but I see a whole lot of back and forth where people are making a whole lot of assumptions about any given situation. And I think it's like, if you've had enough diversity of experience in your life, it gets hard to make so many assumptions because you're like, I don't know the rest of the details here. So I guess, yeah.
Would you say having worked in the IC changed your views on anything that you work on today?
I mean, I think I have a very, very different perspective because of, spending like 9 years in the intelligence community, seeing this, a lot of things from the other side. I also I am one of those people who is 100% supportive of mandatory service, not necessarily like military, et cetera. But I think people make a lot of assumptions about how their government works, having no exposure to how their government actually works.
Mm.
And it kind of feels like people don't have skin in the game. So I think, if you want, like, it's funny. I did the Marine Corps. My brother did the Peace Corps. My sister did AmeriCorps. We all did like very different things, but we all did like some term of government service. And I think it's a very useful experience.
Yeah.
Do you feel like people's ordinary model of like, especially the offensive work that the IC does in computer security, do you think people have a good mental model of how that stuff actually works?
In parts. Now, remember, my knowledge is stale.
Sure, of course.
By many years now. I think people sometimes make a lot of crazy assumptions.
Although like there's a standing meme in our community that like once you're at the NSA, when you leave and go back into industry, now you're an asset. It most often comes up with Dave Vitale. I think it might be in Nicole. I think it might be in Nicole Proroth's book about how he's an NSA asset.
It's hilarious because frankly, there are a lot of people at NSA that were like during my time there, were not happy with Dave. Like the notion of left NSA, went to the line of business that he did, et cetera. Yeah, I don't know. But Dave's also always been a very outspoken, very direct person. He's mellowed over the years, certainly. But yeah, I do remember my time at NSA. Dave and I were both in a program called SNP, which was like it's like an interdisciplinary program. And I started it a few years after Dave left, and there were still stories about interactions, or it wasn't even stories about interactions. So just people had opinions.
Mm-hmm.
But yes, I am 100% certain Dave has never been an NSA asset after leaving NSA.
I'm a kind of Dave Vitale admirer, and that like there's a South Park episode called Simpsons Did It, where like the punchline of every joke is that like every joke came from the Simpsons first, and he was my Simpsons Did It for a while, and I gave up on ever getting ahead of him on stuff and moved into cryptography, which is why I'm here now. And
yeah, I think Dave was a very polarizing figure back in the day, not just among his former government colleagues, but in general, Dave was a very polarizing figure back in the day.
I also have a lot of admiration
still a
for
polarizing figure.
Oh, I guess I find Dave much less polarizing, but maybe that says more about me.
I have a sort of built-in admiration of polarizing figures to an extent. So,
I mean, also I like Dave. I find his input very useful. He's genuine. Like I will say, the hardest thing or one of the craziest things for me was when I started moving into like the privacy space. There was almost like an aversion to the idea of coming up with threat models and trying to like scope the problem, because people wanted the flexibility of not having threat models and being able to sort of ad hoc define things no, this is not like now I'm not talking about like private space in terms of like, when you're actually like speccing things down to like anonymity levels and blah, 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 that. I'm talking about things like, we put out this new privacy feature. It's like, okay, what's your threat model for that privacy feature? It's like, it's a privacy feature.
Yeah. That sounds stressful though. It sounds like everything's in scope. That sounds very stressful as a defender.
Yeah, this is the problem. The privacy space is so I remember the security space back in like the mid 90s or whatever. It was basically lots of security, like lots of AV, lots of security products, stuff like that. Not much in terms of like, hey, let's actually re-engineer these things. Like I totally remember what Thomas was talking about with the whole, like, replacing stir copy everywhere. Microsoft really did care, really did put in the time and energy to make some significant changes. But the first several years of my exposure it reminds me of the privacy space right now, where it's just lots of people saying, look, it's a no coherent threat model. It's like, look, it's a privacy thing. So I guess I don't know. I guess what I'm kind of saying is that I would like to see like a Dave Vitale in the privacy space, or more people like that who will like directly sort of like call things out when it's just ambiguous crap.
Mm-hmm. This leads me into one of the last things I think we have time to talk about: organizational mindset about security and privacy in Apple versus not Apple. Maybe that's in Google or in Android or in Chrome, because it seems like iOS should be very secure. It has good bones, like architecturally, it has good bones. And yet they say that they care about privacy, but it's like define that a little bit more, especially some of the things that they've been pushing out lately versus not Apple. And it seems to be an organizational thing because like we started this talk basically saying like we know so many amazing security and I think privacy people working at these companies, but then it kind of peters off.
I mean, I think, you can talk about like there's different engineering disciplines between the companies, and you guys have good insight into Justin, or you in particular have good insight into the engineering culture differences. But like, I feel like Apple's bona fides on privacy technology are pretty solidly kind of like they did a lot of work that wasn't published for a long time, but is now published. Like, for instance, like the Quorum HSM work for the pin lookup for iCloud and all that stuff, right? They put a lot of engineering effort into stuff that other people aren't even considering doing. The enclave process is another thing, right? Like that was nowhere before they did it, right? They do a lot of stuff that they're not required to do, but just because they take the problem seriously. I tend to come at these things as, like, as a last thing to talk about. I think probably iOS CSAM, probably not the best thing for us to open up right now, right? But like any technical work that they say, or any engineering work that they say that they're doing, or any safeguarding work that they say they're doing, I tend to believe them and kind of take them, in good faith on that they put the effort in. That doesn't mean it's the right thing necessarily for them to do. My feelings about that are super, super complicated, right? But like, I wouldn't put that down to a culture of not caring about it. I think they probably like.
I guess I'm trying to get at like it feels sometimes like iOS, macOS security culture is resting on its laurels in terms of good architectural things, but then like reintroducing the same bug fixes, like they fixed a vuln and then it came back and they had to fix it again like several releases later.
It's the engineering rigor,
Okay.
And this is my personal take. Interacted with Apple quite a bit over my time at Google, particularly when we shared a code base with WebKit. And I think it is fair to say that the team in Mountain View was essentially doing the security work that for both of the browsers at that point in time. And my perspective interacting with Apple over the years is they have very good people, but the number of people they have, it's weird. This is a recurring pattern across Apple. Like the number of people they invest in something, like Apple put, a person on it, Google put a team on it. This is kind of like a mentality. Google will over-engineer and overdo things. I have observed this. But like you look at, so Apple's been getting a lot of hits for fairly dodgy web standard support, basic functionality that works in other browsers, but it's buggy, unreliable, et cetera, in Apple. And this has been my experience. It's sort of a recurring pattern with Apple where they're just, that stuff requires a larger team of people just churning through bugs.
Right.
So with the thing you said about good bones, it's like, I think there are a lot of I think there are a lot of things with like good designs.
Yeah.
I actually think Apple's design for notarization is actually a very good design.
Right.
And it is a design that I think makes a lot of sense if you want to get most of the essentially anti-malware benefit of an app store without actually having to have a closed app store. I think their implementation of it has been terrible. But the actual design and architecture and the ideas behind it are quite good. The way you fix that is you throw a bunch more engineers at it to churn through the bug list and fix it and make it good. And I think particularly post Aurora, security engineering excellence just became a thing at Google. It's like, well, obviously we are amazing engineers, and so our security engineering must be amazing. And so it's sort of easy to to work that way. I don't know how you get that. So it was okay. We would throw a whole bunch of people, a whole bunch of engineers to just churn through the bug list. I don't know how you get that same kind of like culture. I don't know how that you get that connection at Apple.
That like paradigm shift in identity when you haven't had something like Aurora happen to you. And
although I feel like they keep having they do keep having these things happen. Like, remember, Microsoft got hit with a whole bunch of worms until they, they had to seriously internalize it. Microsoft really wasn't hit directly that much.
That's true. There's lots of little things.
Yes. And I feel like Apple should be at that point where they're like, okay, we just have to accept that this isn't the thing where it's like the whiz bang shiny new feature, you mark it out, you're good. This is the thing of to do it right, we need to throw a bunch of bodies at it, and they just need to churn through a bug list.
And
because
practically
that-
all over the place. They have to be like embedded and distributed. It's not just like,
Yes.
well, we're going to throw like 1,000 engineers at iMessage and we'll be fine, or, you know, whatever. It's all over the place.
Yeah, and that was sort of like the Apple people on WebKit and Safari prided themselves on having a fraction of the size of a team.
But-
The equivalent Chrome people.
Yeah, but like the bugs, like, you know, that's, you know, maybe you could be proud of that if you haven't had like a 0 day and like every, you know, patch, every release. It's like, yeah, this was a 0-day vulnerability and it was found by somebody else.
Yeah, and that is my take on this. That it's one of those things where when you're one of these big companies, you'll get to a point where you're like, look, we have to re-architect things so that they're intelligent things that we can do to make this better. And I do see Apple doing a decent amount of that. But the other pieces, and we have to throw the bodies at it to fix all this damn stir copies.
Okay.
And I don't see them throwing all the bodies at it. Like, no. New is bang technology that solves this. It's like, no.
It's like an innovation versus maintenance thing almost.
Yeah.
It very much is. No, I think that's exactly it. It's like my sister works in urban policy and planning, and she's like, we don't need people building new bridges. We need people fixing the bridges we have.
Yep.
But people only want to build new bridges.
Yeah. That's exciting and fun and
and
novel.
you get credit for it. Yeah, you get your name on the bridge potentially. And
Bringing us back to Fuchsia.
Yeah. Well,
it's a fair point that Fuchsia is a new thing. But
I don't know how much I disagree with the argument about, like, I think there's a place for big moves too, right?
Yeah.
So-
yeah,
it's
I
not
think
like
that's
no
it.
one's been doing the maintenance on Linux for the last 20 plus years.
it's not like
Right?
Google in particular hasn't been doing a ton of them, particularly the security maintenance. You have people like Case Cook, who is just like, there are times where I'm like, wow, he is like single-handedly the protector. He's not single-handedly, but he's sure doing a lot protecting Linux.
Feels like it.
At times, certainly. But yeah, there is space to do big new things. But I would say part of the Fuchsia thing is they're also doing all of the little work to get it right.
Nice.
I need Case Cook on just to run us from like 4.x up to current 5. Just there's a blog somewhere and I try to keep up with it, but there's just so much stuff going on.
Yeah, the stuff he does is just. This is one of the things I really loved about working at Google. The amount of like just public and open source contributions that you get that you get to do, you feel good about that. It's not that there weren't upsides and downsides to be at Google. It's not that Google's a perfect company in any way, shape, or form. But I'm very proud of the vast majority of what I did at Google, and I like the fact that I got to make so many public contributions in my time at Google.
Yeah.
I'll ask you one last question just related to that. So I think a lot of us probably already know about the work that Case Cook does. Is there somebody else besides them that we're not paying enough attention to that your work has brought you into contact with in the field? Come up with one real quick.
Abhishek Arya.
Oh, I know them.
Yeah, he so he was my first you're a mentor for a noogler that comes on board at Google. So a new employee starts at Google. So he was the first person who I mentored at Google. Had just joined Chrome Security, but he's a principal engineer or director. He's an exec now, but he's essentially responsible for the big fuzzing efforts like cluster fuzz. Yeah, cluster fuzz, OSS fuzz, all of that. It was like, it literally started as him grabbing interns workstations as they would leave. Like they would leave for the summer, he started grabbing their workstations and was stacking them under his desk to run fuzzers.
Yeah.
And then that evolved from his legs basically getting burned by all of these Xeon workstations under his desk to like moving into the cloud and all that. And now, he's like in charge of an entire team. And just, it's another one of those things. It just has a huge impact on the industry as a whole, like particularly with OSS fuzz, where they're just basically like, hey, we're just gonna, all of this software is important. We are going to give you a framework for building fuzzers and running against it. It's amazing how much it's evolved. And the fuzzing stuff that they've done, they keep incorporating all of the new advances in fuzzing in terms of like the different, the input guided, and I forget the names of all the different kinds of
coverage
fuzzing
guided
stuff.
and
Coverage guided, yes.
Yeah,
that
they
was what I was looking
support
for, yes.
they support like AFL, and they support multiple different kinds of fuzzers. They did all the documentation to help you get a Rust binary covered and automatically updated, and they'll automatically report. It's extremely valuable because I tried to set up an instance of cluster fuzz and I had it and it was like, okay, I could do this, or everything could be open and they could report it. I could use OSS fuzz to report back to me. And
Yep.
it's like, it's a non-trivial amount of work to just make that project go. And it's extremely valuable to just anyone who just sets up a fuzz target. It's great.
Yeah, you got your open source software. You can just set up a fuzz target. I mean, it's not entirely plug and play, but it's about as close as you can get to plug and play when you're dealing with fuzzing. So yeah, that whole team.
You can run your fuzz target as part of your CI, but the whole point is that you got to keep it going. You got to keep
Yes.
throwing the computers at the fuzzing, or else you may not get the full value out of it. And that's the hard part of cluster fuzz solves.
Yeah, I don't get the thing where people have been trying to run fuzz targets as part of CI. That's kind of like I'm just going to breathe oxygen
Yeah.
for like a minute or two, and then I'm going to go about the rest of my day. And it's like,
It's
no,
like-
that's not the way fuzzing works.
Yeah.
Awesome. Okay. Well, Abhishek and also OSS Fuzz. Excellent examples. Thank you, Justin, so much for being here.
Thank you,
Thanks, it's
Justin.
been a lot of fun.
This is
Thank
cool.
you.
All right, I'm hanging up. Wow.